students. I think so we have done up to exercise number 4.1. Yesterday we have done question number 3rd and 4th. Now we will do the question number 7. Let us suppose we will start the question number 7 of determinants chapter 3. Yes, exercise number 4.1. Now question number 7 is saying, question number 7. Now what it says, this question is saying that find the value of x. Find the value of x if you have given that of 2451 is equal to your that of 2x 4 6 and x. Now here you have given some sort of the determinants and you have to find the value of x. See how to do it. As you know, we are doing the questions as per rule of the determinants. We are doing the same way the questions. I'll write down the first questions first. Same way here 2x 4 6 and x. Now according to rule of the determinants, we go first 2 multiplied by 1 minus 4 multiplied by 5. This is your left hand side and your right hand side will be multiplied 2x into x and multiplied 4 into with minus sign 4 into 6. Now in this case your value will be 2 and this will be 20. After solving, this gives you 2x square minus 24. Now this is minus 18 left. Here you are 2x square minus 24. I'll take 24 here. Your value will become out 24 minus 18 will be 2x square. This gives you 6 is equal to 2x square. Now 2x square is equal to 6 and x square will be 6 by 2. So your value will become out 3. So x square is equal to 3 and x is equal to plus minus under root of 3. So this way you can find the value of x in this case. Now we'll do the question number 8, which is little bit similar kind, and I'll try 2 questions so that you more understand how to solve such kind of questions. So see question number 8. Now we will do the question number 8. Question number 8, as it tells, if you have x 2, 18 and x, it is in that, and you have equal to 6 to 18 6. In this case you also find the value of x. Find x. Now how to do these questions? We will go solution. Now you can write again the question x to 18x, which is your 6 to 18 6. Now in this case you would again go as per the rule, multiplied x into x. Your left hand side will be x multiplied by x minus, again you multiply 2 into 18. This is your left hand side, and on the right hand side, similar way you multiplied 6 into 6 minus 2 into 18. So your value goes x square minus 36 is equal to 36 minus 36. If you can see, right hand side goes to 0, your x square minus 36 goes to 0, x square goes to 36, and now x value will be plus minus 36, which is your x value goes to be plus minus 6. So this is your again answer by similar kind of questions. Now we will do the questions further, that is the exercise number 4.2, and these questions are a little bit different as the previous exercises. See these questions how to do. Now this question is something like this. You have using the property of determinants, using 4.2 question number 1, using property of determinants, properties of determinants, using property of the determinants, and without expand, and without expands, solve. Now this is the questions, and you have x a, x plus a, then y b, y b, y plus b, then z c, z plus c, and you have to show that this determinant goes to be 0. Now how to solve these questions? To solve these questions, we have to similar way as per the rules of the determinants. Now I'll write down first your same as values and applying the rules of the determinants to solve these questions. Now you know that in these operations I'll use the operation C1 stands to C1 plus C2, C1 plus C2. You know that as you have seen, C1x plus A is already given in the C3 column. So that's why I am using this operation. So operation using C1 stands to C1 plus C2. So your value goes to x plus A, y plus B, and z plus C. This is your C1 operations, and your C2 will be as it is, and x plus A, y plus B, and z plus C. This value goes to be similar kind of value you have find. But as per the rule, as you know very well, when I taught you the rules of the determinants, I'll give you one rule. If two of the columns of the determinants are same, the value of determinants will be 0. So you know that C1 column and C3 columns are same, hence the value of determinant goes to be 0. So you can say, since C1 and C3 column of determinants are same, so by rule of determinants, its value will be 0, which is right hand side. So hence prove. So this is the answer of these questions. This is a very smaller one, but you must have to check it out. If two of the columns are same or two rows are same, then value of determinants goes to be 0. So this is the question number your 1. Now question number 2 we will do the same way. Now what we had to be given in that question number 2, little bit different. Now see what question number 2 is saying. Question number 2 is, you have a minus b, b minus c and c minus a. This is here. Now b minus c again, c minus a and a minus b, and c minus a minus b and b minus c. So this determinants also gives the value of right hand side as mentioned 0. Now how we can prove it? Similar way we can treat it. Let us suppose we tried R1 row tends to R1 plus R2 plus R3. Now see what happened. If we then use this one, so what we stands like A minus B plus B minus C plus C minus A. This is your R1. Then we can use B minus C as it is, C minus A as it is. I'll operate only operation I'll done the operation in R1 to R1 plus R2 plus R3. Now see next of the part, then B minus C plus C minus A plus A minus B. So this is your, rest of them will be the similar kind. And now in the third part, that is your C minus A plus A minus B plus B minus C, and here is A minus B and B minus C. Now I'll use this one. See, B goes off, A goes off and C goes off. So your value will become out 0, B minus C, C minus A. Here also B goes off, A goes off, C goes off. Your value goes off 0. So 0 is C minus A minus B. Now here you will C again goes off, A again goes off, B again goes off. This gives you 0. So A minus B and B minus C. Now in this case, you would find the R1 row goes to 0. If we can open these determinants by R1, then definitely its value goes to be 0. So you can say open determinants with R1 row, so value of determinants is equal to 0. So which means the right hand side is equal to 0. So 0 is equal to 0. So your value goes off. Open determinant with R1 row. So value of determinant goes to be 0. So hence proof. Hence proof. So this way you can do these questions. There are so many questions of such kind. You try some of them. In case if you find difficulty, because my link is given in the last of the video, so you can either WhatsApp me so that I can solve your problems. Okay, thank you.